Hey guys, it's Mr. Zora here, talking about general form to standard form. So far we've been looking at parabolas mostly in standard form, and it's time for us to take a look at some more challenging ones. Our objective is to put these parabolas in standard form so that we can locate their focus, their directrix, as well as show their focal width, and of course the vertex. Let's get started. So I have a guided example for you, and I have 3 problems for you guys to check out, which really 3 problems is more than enough because you have multiple items that you have to locate for each of the problems. So I'm gonna show you how I did this with desmos and how desmos can really help you out when you're doing these steps. All right. So first of all, here's my, and let me turn the rest of these guys off. Got my work ready, prepared. All right, I will turn everything else off, including this. All right, okay. So the problem is 4x squared minus 24x minus 40 minus 4 at minus 40y minus 4 equals 0. And you have to turn that back into vertex form, back in that standard form, similar to vertex form. So the way we do this is I actually wrote every single one of my steps in a desmos cell. And the reason for that is if I do that, I can see whether or not my step is correct if it produces the same graph. So here in my second step, which you see produces the same graph, blue on top of red, I factored out a 4 from my x terms. All right. And what I'm going to do with this is I'm going to end up completing the square. So I factor out a 4, and then I moved my 40y to the right side because what I want to have is my x's on one side, my y's on another side. I'm going to try to put this in y equals because the squared term is the x. All right. So you'll notice the next thing that I did, my third step, which is equivalent again. All right. I'll show you. It is equivalent. So for my next step, what I did is I completed the square. So if you remember with completing the square, you take your b term, which right here is -6. You cut it in half and then you square it. So -6 divided by 2 is -3. -3 quantity squared is 9. So 9 is the number that completes the square right here. So I completed the square with 9. I still have my -4. And now look, I also subtracted 36. And the reason I did that is because 9 times 4 is 36. I've really unbalanced this equation by 36. So I didn't just add a 9. I actually added 36. That's why I'm subtracting 36. And you'll notice that on my right side, I still have a 40y. All right. My next step, again, equivalent. You'll notice it is correct. Is I went ahead and factored x squared minus 6x plus 9 to x minus 3 times x minus 3, which is x minus 3 squared. I went ahead and combined my -4 minus 36 to a -40, and I've got a 40y on the right side. So really the last thing that I'm going to do is I'm going to divide both sides by 40. So I divided the 40 into the 4 and into the -40. All right, as shown. And still the same parabola. And when I simplify, 4 40ths is 1/10. And 40 40ths is 1. All right, so now I've got this in a times x minus h squared minus k, or plus k, equals y. There are some textbooks that put this -1 over here on the right with a y plus 1. Really, it's the same thing. So after this, I go to use my formula, c equals 1 over 4a. I substitute my a value, which is 1/10. All right, I get c equals 1 divided by 4 times a 10th, which is 1 divided by 4/10, which is really the same as 10/4 or 2.5. So this tells me that the focal length is 2.5. In other words, from my vertex to my focus, there's going to be a distance of 2.5. Also, from my focus to my directrix, there's going to be a distance of 2.5. So first thing I'm going to do is I'm going to label the vertex. All right, and there it is at 3, -1. I can tell that from the equation. Then I'm going to add 2.5 units to my vertex to find my focus. I do this along the axis of symmetry. So I keep my same x value, 3, and my y value is 1.5. Second to last thing I'm gonna do is locate the directrix, excuse me, the focal width. So if the focal length is 2.5, then the focal width must be 10. So I graphed the line y equals 1.5 from -2 to 8, which gives me a width of 10. And then the last thing that I did is I graphed my directrix at -3.5. Make sure you try it out on your own.